Everyone. I'm Sharmila Ravula, the CEO of BITSAA Silicon Valley chapter, and you're in the third lecture of the Business Analytics series, which is part of the BITSAA Propel program, which we have recently introduced. BITSAA International and BITSAA SVC have introduced recently to increase the interaction between alumni and campus students. So thank you again for joining us today. So I would like to just, as quickly as possible, allow Harsha to talk about his experiences and the specific topic that he'll be covering today. But a few fun facts about Harsha. He graduated from the BITS Pilani Goa Campus in 2008 and has an MBA from Duke University here in the US. And currently he's the Director of Cloud Data and Analytics at Microsoft. And a quick peek into his BITSian life, which is the most important part of our lives, has always been. He survived the first semester without internet or power for more than 30% of the time, which I think is a huge challenge if you think about it from today's in today's day and age. And another fun fact is that he organized Ugadi, which is New Year, and managed to get cooks from AP to prepare food for more than 4,000 students over 3 years. Since you're going back to the mess to eat food, I'm sure you appreciate that. And he also visited the Pilani campus from Goa for Apogee. So with that, Harsha, welcome and thank you for your participation in this lecture series, and please take it away from here. Before we do that, I've just posted the Slido link for all the students. Please post your questions there. I'll be moderating this. I'll be moderating and picking the questions about every 15 to 20 minutes. So Harsha, if we can take a break during the lecture every 15 to 20 minutes and address some of the most popular questions, we can then move to the next section. Hope that is okay with you.
Yeah, that's perfect. And Jai Shri, Sharmila, and Professor Brai, I'm incredibly grateful for the opportunity to come back to, at least virtually, to campus and share a few thoughts. Let me share my screen, and I want to make sure you're able to see the slides. And if you can confirm, I can proceed with talking.
Yeah, it's fine. We can see your slides. Thank you.
Awesome. Yeah. No. First of all, I wanted to start off by saying a big thank you. It's an immense pleasure and honor to come back to campus. It's been, I would say, at least 7 years since I've had any formal interaction with BITSians, and this opportunity, and I think the way the BITSAA Silicon Valley chapter is trying to bridge alumni to people on campus, so you can get the best exposure and kind of talk to the best of BITSians that exist. And I think a lot of the world is driven by BITSians. So I'm also incredibly proud to have the opportunity to graduate from BITS. Just to give you some background of who I am in my journey, and sort of for you to understand some of the context in which I would speak. So I graduated from the Goa campus in 2008, worked at Oracle in their data and AI team. This was way back in the day when cloud was very at its infancy. There's not a lot of compute that existed in the cloud. I then worked with QuickBond Consulting, a Hungarian retail consulting firm, came to the US to get my MBA, did my MBA and focused on decision sciences from Duke. So again, extremely data focused and analytics focused MBA. And then I started Microsoft as part of the rotational leadership program. And I've been with Microsoft over the last 7 years. Now I run $1 billion business for Microsoft, focused on data and AI and retail and consumer goods. Um, I know Sharmila covered a lot of, some of the fun facts about my BITSian life. The one thing that I did not share is I'm a BITSian, obviously. My wife is a BITSian. My elder brother is a BITSian. My sister-in-law is a BITSian. My brother-in-law is a BITSian. So we've we we are a BITSian family. So I have a lot more attachment than the usual BITSians that you would find. I have a couple of kids, Rohan and Surya, 3 and 1, incredibly passionate about cricket, trying to raise my elder son to play cricket as much as possible. And like I said, yeah, and my wife is also into data science. So, very common theme across a lot of these things is data. And hopefully, as I talk today, you probably get a sense of some of the trends that I'm seeing in the industry and in how you could use some of those learnings and sort of build your own learning curriculum over the next year if if you're going through your MBA program, and then also when you graduate and sort of go into more of the industry kind of focus on. So, if I were to fast forward to the next, let's say 20-25 minutes of I'll try to keep my commentary to a minimum so I can take as many questions as possible. The top takeaways from today's session are going to be you would get a framework for thinking about the impact of data analytics and the role that it plays in organizational transformation. I will, throughout my time at Microsoft and before coming to Microsoft, I worked in several industries. So I'll give you an example, starting from sports to keep it interesting, real estate infrastructure, retail, e-commerce, and sort of then really take a lot of the framework and the examples and boil it down to, if I was a student back at the Pilani campus going through my MBA program, what would I do if you wanted to build a successful career at the intersection of business technology and analytics? The first thing I think, that as like the title says, I think it's important to make sure we talk about what transformation means in the organizational context. In general, transformation is essential for humanity evolution in general, and it has been true for organizations as well. And I really like this Darwin quote where it says, "It's not the strongest and the most intelligent who will survive, but the most who can manage change." And this has been true for evolution. This is also true for companies that we all work at. If you look at, and I'll show some of the trends, if you look at what has happened over the last 20 years, it's people or companies that really were able to keep pace with change, were the companies that were able to survive. And transformation is sort of quintessential for corporates to exist. And then you have the opposite of transformation, which is disruption. So if you're one of the top companies, there's always, in its purest sense, disruption doesn't have a positive connotation. It creates a disturbance to an event, a business, a product, a service, an experience, and it's something that could be unplanned for companies. And in some cases, as with the pandemic, it can really disrupt your supply chain. It can introduce a lot more risk, and things that were guaranteed to happen over a period of time won't necessarily happen. So disruption is what companies guard against. And if you really look at what happened over the last 20 years, many of you probably have seen this chart before, where if you look at what was going on in 2001, you have an industrial conglomerate in GE, the top market cap company. You have Exxon Oil and Gas. You have Citi Financial Services. You have Microsoft in tech. And this is the post-bubble scenario. And then if you fast forward to 2006, you still have a very similar mix. You have two energy players now, oil prices raising. Exxon in sort of total were in the top 5 market cap companies. I won't bore you with the detail. Microsoft dropped off the charts in 2011. And then in 2016, if you look at every company that is there, it's all the tech players. And disruptive models in tech are very common. And the great thing about some of these tech companies is they continuously reinvent themselves in a lot of ways that many others haven't had to in the past. As an example, for our in the case of Microsoft, also, if you think about Microsoft's legacy business of selling office solutions to customers, high margin product, selling database licenses, again, a high margin product. And then you have someone like Amazon that came, disrupted the software model with their cloud. Microsoft had to go back to the drawing board, reinvent themselves, came back really strong after Satya became the CEO. And so you sort of see the evolution of that transformation that the company had gone through to now, be where Microsoft is one of the top market cap companies. But the underlying trend that I'm trying to highlight is if you look at all the top market cap companies pre-COVID-19, and if anything, COVID has only accelerated this trend. Transformation is essential. I think tech companies have in general figured out how to transform, because if they don't transform, they don't exist. It's not, and tech changes more rapidly than any other business. And so somehow these companies have figured out how to create a moat around their own existing offerings and continuously disrupt themselves by inventing new business models and creating more economic surplus through their products, etc. Now, transformation, if you think about transformation as a concept, there are 3 key things that you'd have to really think about, right? You have to first figure out what organizational metrics would you capture to, what would you measure and capture? And it could be something like, floor productivity on a manufacturing plant floor, customer retention metrics, employee engagement, in customer satisfaction, right? Once you figure out what these parameters are, you have the infrastructure to be able to measure them, you then take some of these metrics and then spend time really thinking about how do you translate these metrics into really key business drivers. So you really spend time understanding what those business drivers are based on the metrics that you're capturing. And then using the data and your interpretation of the data, you have to reimagine the future. And that is very essential for every company when they really think about transformation. At the core of it, analytics is nothing but these 3 things coming together. And when we really think about analytics and how organizations need to think about analytics, they have a very limited or sort of very defined view of just the measure aspect. People define it as something that you define the metrics, you measure those metrics, and you display those results in a dashboard, or send someone a report, or generate a forecasting model and generate a forecast and give those results to someone within marketing or finance or supply chain. And that's a very limited understanding or view of analytics. What really, if you really have to build skills and be really prepared for the future, what you really need to have is be able to take those metrics and then really spend time kind of applying the domain expertise on top of the metrics to be able to translate those into meaningful business outcomes that then you can help with the strategy for an organization. So at the core, these are the 3 key pillars for any sort of analytical process within, whether it's predictive, descriptive, analytics, and sometimes even standard reporting. You have to really think through this cycle. Now, as a student, one of the things that I would take away from the first section of what I'm talking through is you have to, I think there are three really key elements as to where the value for these organizations would come from. If you want to be a leader, and some of the elements of being able to help with the company's transformation using analytics is a core requirement these days for most companies, especially with the model sort of shifting digitally, et cetera. So you got to really think about three elements, right? One is having the domain expertise that the industry that you're operating in. If you're a retailer, like what is really happening in retail, healthcare, manufacturing, commercial real estate, you have to have the domain expertise, because at the end of the day, it all comes down to how do you take some of these and sort of apply within the domain that you operate in. But there are two other elements that are really, really critical along with the domain expertise, which is having an analytical approach, right? We talked about that, having the ability to measure, sort of understanding how to interpret data, et cetera. The last thing is technical awareness, and I would tell you that when I was a student at Duke, we didn't realize as this aspect as much as it is today. I can't tell you a CIO or a CEO or a COO within an organization today that is not completely in touch with technology. Because any business model that they need to think about this hybrid of digital plus physical. And unless they are technically aware of the possibilities that technology can make happen, it's almost impossible for them to continue to maintain a competitive advantage in the world. So one of the key takeaways from this segment is that you have to, as a student, you have to focus on all of these elements as you think about building your own career growth, or in general, like your edge within an organization is not going to come from being good at one or two of these. You need to be really good at all three of this. Now I'll sort of shift from talking about the value piece of where you would drive value to how are companies really thinking about digital transformation, right? For every organization in the world to kind of succeed in unprecedented constraints, so you think about a big company like Microsoft, or think about a small manufacturing company in India. All of these companies are facing some amount of constraints. Either sometimes it's lack of capital, sometimes it's disruption in supply chain. You need to really figure out how do you empower people, fostering a new culture where data becomes the core of how they take decisions, and then figure out how do you engage those employees to deliver better customer experiences. Because at the end of the day, every business needs to be able to delight customers. And how do you take that data and then transform products in a way that you create a significant delta relative to every other competitor in your market, and then figure out how do you optimally deliver those products to those customers by optimizing your operations. At the end of the day, digital transformation is being able to touch all of these different pillars, and the way you do that is through tech intensity. And tech intensity is a concept that some companies have come up with, and the way tech intensity is defined is it's how do you really adopt technology within an organization. And I'll give you an example of a legacy business being transformed or completely disrupted by technology. But then how do you create the capability within an organization to be able to create those technically competent products where you're able to learn, act, and then test, and then act really quickly in the market using technology. And then the exponential function is how do you create trust both within the organization and also for your customers? This is how tech intensity is created. I would say data intensity is almost the same formula, if you will. How do you create in data intensity sort of analytics, use whatever you'd want to use there, but how do you create adoption within an organization where people are driven, make data-driven decisions? But then how do you have the capabilities within the organization to create those analytics? And then how do you create trust within functions of an organization to be able to take decisions based on data versus their own gut feeling? I'll sort of take a pause there and see if you have any questions before going into how is cloud really changing all of these aspects.
Thank you, Harsha. So let me quickly check Laudo. There's one question posted here. What does a business analyst actually do in a project?
Yeah, no, that's a great question, and something that I will cover as part of the examples of companies that I really talk about, and then I can come back and see if that addressed the question or not. Is that fair?
Sounds good. Again, awesome. Folks, please post your questions on Slido. We are using that approach as compared to looking for raised hands in this forum. Go ahead, Harsha.
Thank you. So how has cloud really impacted all of what we've talked about so far? The first area where cloud has really changed the equation is the rate of experimentation. And as you become leaders for tomorrow, you got to really think about just like in 11th grade, 12th grade physics or chemistry. In reality, a lot of really innovative concepts or products come out of experimentation. And the reason why startups are extremely successful in disrupting like big players is it comes down to really two elements, right? It's the rate of experimentation that they can get to, because the speed at which they can deliver and the cost of at which they can innovate or experiment is extremely low. And you got to think about, even when you work for big organizations, you have to somehow figure out the model to where you are able to experiment very quickly and at the lowest price point possible. And the first example that I'm going to give you today is and just to keep things interesting, is from Hendrick Motorsports. Hendrick Motorsports, and for those of you that are not familiar with motorsports in general, like think about F1 kind of racing more so with a different, almost like consumer cars that you see in the space. And it's called the NASCAR in the US. And if you think about how, one of the elements in sort of give you some background of the challenge that Hendrick Motorsports deals with, they go about 100 to 200 miles per hour in races. So you can think of that as more than somewhere around 200, 250 kilometers per hour to 300 kilometers per hour. And they go around in circles. And at any point in the race, they don't know how much fuel is left in the tank. Because you go at such high speeds, there's a risk that you'd actually wear your tires out very quickly. And then if your tire wears out and something happens, you basically get out of the race because you cannot race anymore because you lost your tire. So you crash and sort of crash out of the race. So they're competing with 40 other cars at any point during the race. The guy who is making sort of think of the coach or the DRS system where you have to really think through the strategy element of it. They're making their decision based on two factors, right? Am I going to run out of fuel, or are my tires going to go out of use when I'm going at that speed? And that really dictates whether they need to take a pit stop or not. And the rate of experimentation here came in where they said historically, a lot of these guys that got paid more than $1 million, what they did, $1 million a year, what they did was they basically used their own human intuition based on the state of the race, etc., to basically make the call on when to take a pit stop, right? Now, when they approached us, what we started really thinking about is how can you really disrupt that decision-making process to make that be 100% entirely driven by data. And we started taking a lot of data from the car post-race and started really thinking about things like what is the weather on that particular day, who's the driver. They have 4 cars, so off the 40 cars, Hendrick as a brand owns 4 cars. So who's the, we're taking data from all the 4 cars, who's the driver that's driving the car, what track, so different race tracks have different attributes. You take those elements, and then you take what speed that they were driving at, so you get that real-time information from how fast they're driving, and then you know how much what is the fuel tank capacity. Using all of these elements, we built a model that costed them less than $100 to be able to run the model on a race day. And we've really replaced the uncertainty associated with that race with a cloud-based predictive modeling tool on Azure. But the real key is a couple of guys, me and a friend from who's his origins are from China, and both of us know nothing about NASCAR. Just like many of you, when I started working on this project, it was 2016. I really had no clue about how the game is done. But the beauty of this whole process is we were able to experiment with a lot of models relatively quickly at low cost of failure. If they lose $100 and they don't get the most accurate result, that's absolutely fine. But historically, if you dial the clock back to pre-2010, the same process would have taken at least a year before you were able to gather all of these elements and then make decisions based on that. Whereas within 4 to 6 weeks with $100, we were able to make game-changing decisions. Another example from the same scenario that I would give you in how analytics has really changed the equation, or cloud has really changed the equation in terms of analytics, is they actually, to be able to judge how to structure their cars, they run a simulation model in a wind turbine. Just to give you an example, they spend around 50 lakh rupees every night in electricity, just alone in electricity, to be able to run the simulation on the car in terms of figuring out what the airflow looks like on the car. We replaced that entire process using artificial intelligence simulated models with less than about $1,000, which is close to around 72,000 rupees. And what used to take about half the electricity that the entire city of like an Ahmedabad would consume down to a single cloud model that can do the prediction over an hour, whereas for them to go into a real wind tunnel and simulating the aerodynamic nature of air drag resistance on the car. The 2 elements are the speed at which you can, and the industry operated like this for 20 years, is really replaced that and said, how can you use the cloud to replace that entire process and deliver innovation with the lowest price point possible at the fastest time possible. And as you think about your own when you go into the industry, you have to really think about how do you take every experiment is costly. Companies don't like to bet on things that have uncertain outcomes, but it's your job as a leader or as a thought leader to really think about how do you lower the cost of failure or cost of the experiment in general, and then how do you accelerate the process or the time it takes to get to a binary outcome of whether something was successful or not. The next example that I'll give you, which is where I'll talk about what business analysts do within a company, is business model disruption. cloud really changes because of the way the cloud operates at the edge and in the cloud, and lower cost of compute, lower cost of storage really contributed to business model disruption. The example that I want to talk here about is a company called ThyssenKrupp. ThyssenKrupp, they wanted to disrupt their own sales and service business model. They reached out to one of our teams and basically said, if you think about an elevator, let's say in a commercial building or a hotel in India, people sell an elevator to a hotel and basically charge them for the product that they sold, and then they'll sell them an annual maintenance package, and then you have some revenue that you're generating up front, and then you have this recurring revenue model each time an elevator needs to be serviced. Instead of that, some of the commercial real estate guys, just like the Uber or Uber model, they said, why don't you charge me for not the car, not the elevator, but charge me for the ride itself? Now, if you think about that shift in collecting revenue upfront, collecting recurring revenue, that now fundamentally transformed into how do I now make sure people are able to take elevator rides? That means I would never have to have downtime associated with the elevator, because if I have downtime, what would happen is people can't use the elevator. If they can't use the elevator, the company ThyssenKrupp does not make money. So if you think about it, they really now have to change their entire thought process, right? When they were making money for not allowing elevator, or when an elevator breaks down, now they lose money when an elevator breaks down. So they said, hey, how can we use data to really predict when an elevator would fail, and how can we really then transform the model in a way that we intervene or service an elevator before it fails. So it's not extremely clear, but if you see in that chart below, you have a curve where it says what's the normal degradation of an elevator, and you have service points every 45 days or 60 days. They said, how do you build a model where if an elevator is not following a normal degradation pattern, how do you do predictive maintenance, which is sort of the concept here? How do you do predictive maintenance and preventative maintenance on this elevator where you prevent it from failing using data? And they started capturing elements like, what's the door shaft speed, things like how many elevator rides were taken on a particular day, when was it last serviced, what kind of use is it in a stadium, in a hotel, in an office building. All of those parameters play into how elevators function, and when elevators fail, they fundamentally flip the model to really predict. Again, here's an example of business model transformation. So the question then is, how are business analysts in this particular scenario? You have, I'll kind of talk to you with a chart. There are like really 3 or 4 functions within an organization that help build something like this. You have data engineers that are responsible for understanding how do you take a lot of these business parameters that, shaft speed, etc., and collect those variables and to be able to capture that data. That is the data engineer sort of responsibility, is to be able to ingest that data into some form. Data scientists would then take those data points and create models with using different algorithmic techniques to figure out, hey, how can I predict when an elevator would fail? A business analyst in this particular scenario, their role was to be able to first experiment with how do you predict an elevator failure with more than 90% certainty. You need to know what are some of the data points that you need to capture, because you need to place sensors within the elevator to be able to get that data out for a data engineer to be able to extract. And so for that, you need some sort of business understanding, plus also data understanding, right? So business analysts in most scenarios are people who, within organizations, usually people who frame the problem and then interpret the results from a dashboard. In this particular scenario, they have analysts sitting across North America that are observing. You can see the chart there. They're observing that map and figuring out where the elevators are degrading more than what they should, and they sort of figure out how to intervene. So I'll go to the next example. Exponential growth and possibilities. One of the things that you will find with innovation in general, and it's true with the cloud as well, what the cloud really has done is it lowered the cost of compute and cost of storage. And what that did is it offered a lot of companies exponential growth and possibilities of what they could do, even on an annual basis. One such example is Jet.com. Jet.com is not in existence anymore, but because it got acquired by Walmart. But Jet's business model was centered around, hey, if I as an e-commerce provider are able to procure specific, so let's say there are 3 or 4 merchants and there are 7 or 8 items that you can order, and if 2 merchants can fulfill the order with the lowest amount of shipping costs, I will pass on that lower shipping cost benefit to the end consumer. So Jet's model was the more number of items that you add to a particular cart, the lower the price point would be. So if you think about this problem, Jet has a fundamental challenge, because if let's say a customer is in Hyderabad of Telangana state, and you have suppliers that are based out of Bangalore, Chennai, Delhi, name of Calcutta, name a place in India that you have suppliers. And some of the suppliers have all of the items, some of the suppliers don't have all of the items. And then when you have to ship or fulfill that particular item or card for that particular customer, you have to then optimally figure out where you get the lowest shipping cost. If you think about this is in a classic computer science kind of a model. It's a full search problem, because now you have to go through all the merchants, all the SKUs or items in the cart, and kind of traverse every node to get to what is the most optimal outcome for that particular product, for that particular customer, so they can pass on all the savings from procuring from a single. So they started experimenting what is called a genetic algorithm, which is sort of useful information, but then the real challenge is you cannot have enough compute to be able to do a full search on more than 1 trillion combinations. In one of these particular examples, if you really multiply the number of offers for item 1, the number of offers for item 2, and so on, if you have more than 7, you're really talking about more than 1 trillion combinations that you need to search through. When you're shopping, you don't have the time to wait for like the results to come back like you would for a Tatkal ticket, right? You just don't have that level of patience. You'd go shop with someone else. So what they did was they really use AI and machine learning to understand patterns and say, instead of doing a full search, how can I limit my search but still get to the optimal outcome by lowering the number of combinations that I traverse and kind of figure out what the shipping costs are going to be. And that's an example of where they've actually used AI and machine learning to figure out what algorithm what data set needs to be provided for the genetic algorithm to make a decision on to optimally get to the end result in a more optimized manner. And all of this needs to happen at very low price, because as an e-commerce player, margins are not so high, so you cannot really spend $1 gazillion in computational power or to get to that outcome. And so again, this is a scenario where something that was not possible a year and a half ago, Jet was able to use the advancement in the cloud, etc., to really use it to their advantage. Things like innovations like graphical processing units with GPUs coming on board. The same problem just using conventional CPU would have taken about 180 times more time than what it had taken with a GPU. So all of these factors play in. And so the key takeaway or the key message from this example is, experiments that were not possible a year and a half ago, with the rate of innovation that happens in the cloud, you have to consistently revisit and test your underlying assumptions on what's really possible with the latest and greatest technology, which goes back to the concept that I was talking about earlier, which is the tech awareness aspect. The last example that I want to give, and I'll take a pause there, is delivering intelligent experiences. One of the really interesting things about how things have changed in the last decade, especially with data, is most of our day-to-day interactions are with all cloud-based companies. If you think about what you use for your email, whether it's Gmail or Outlook, what you use for texting, whether it's WhatsApp or some other form of text, what you use for shopping with Amazon or Flipkart, or what you use for interactions between BITSians, etc. All of these are SaaS or cloud generated interaction. What really the cloud opens up is, if you really want to deliver intelligent experiences to your customers, it really opens you up to being able to integrate all of these through APIs to create really rich experiences. And one such example is Macy's.com. Macy's, if you think about Macy's, they're like Shopper Stop in India, in the US. Macy's, what they do is they really have different categories of products that you can shop from. And one of the things that they wanted to do was, they have a lot of frontline workers that work in the store. They change very often in the job, and they cannot, as an example, an average employee stays about 2.5 to 3 months. And the systems that they have on the back end are extremely complicated, so they cannot go through 2 weeks of training and have all of that financial loss associated with training a particular employee. What everybody is extremely comfortable with is texting. So what they try to use is, can I use AI to use texting as a mechanism to empower my employees to be able to respond to customers really fast without them understanding all the systems behind the screen? As an example, you go to State Bank of India and ask the teller. Now, it doesn't happen anymore. Most people use mobile apps, but just flow with the example that I'm giving here. You go to the teller and basically say, hey, can you tell me what the balance is? Instead of the teller actually opening up a UI or keying in your account number, etc., how about he just texts a phone number, give your customer ID, and then it displays back your result, right? All of that complexity is abstracted away, and that's what Macy's did. You have, if you're a Macy's employee working on the shop floor, you have hundreds of systems that you need to interact with. What they started doing was, can I use AI to really translate whichever form of question comes in, use natural language processing, etc., to really take conversational, this is called conversational AI, basically take those models back and say, how can I surface the results from different disparate points, or supply chain system, customer relationship management system, etc., and sometimes even merchandising system, bring all of that information together and sort of display the result without the associate needing to have all of that insight. This is another great example of how do you really deliver intelligent experiences, knowing what you would have to go through as an employee or a customer. I'll pause there and see if you have any questions, and I'll try to wrap it up in the next 5 to 7 minutes.
Great. So one of the what are some things, both as an individual analyst and as an organization, that can be done to derive the maximum benefits from cloud solutions?
Well, what can be done to derive the maximum benefit from the cloud solutions. So I think there is really 3 or 4 key things that you could be doing. The first thing is being aware of what the cloud offers that you don't necessarily have to build. As an example, in this particular, it's actually a great scenario for me to talk here. If you think about Azure, and this is by no means an advertisement for Microsoft, or I'm just using Azure. This is the same true with AWS and Google Cloud in general, or Alibaba Cloud. You have already pre-trained models that the cloud service provider provides that you don't have to go build yourself. As an example, if you have to forecast demand for a particular product, you could basically use a regression or build something on a notebook, on a Python notebook, and basically build your own model and deliver the end result. But sometimes cloud providers have, because they've already worked on these, they said, hey, we can pre-build those models. We have these pre-trained models that you can leverage as a service, and you don't have to go through the heavy lifting yourself. That is an example of being aware of what cloud provider provides, and you not necessarily having to reinvent the wheel to be able to get to an outcome that has already been provided as a service. So it again lowers your cost of experimentation. It enhances your speed because you're not building that. That's the first thing. The second thing is you have to really spend time thinking about what cloud can help in terms of edge and the cloud computing perspective. As an example, one of the biggest advantages that you have is, hey, if you have scenarios where you have to do like human detection, thermal detection, or human detection, like somebody's not maintaining the right amount of social distancing levels, and you have to really do computer vision, like using vision AI to be able to detect the distance that people are maintaining between themselves. Being able to really think about that scenario from not just a cloud perspective, but also edge. Edge AI is cloud providers provide devices that can do local compute without having, so any data point that need not traverse to the cloud and sort of do the computation there. So as an analyst, you can really think about using cloud and edge as a combination to really solve for those specific scenarios. The third or the final element that I would say is the best way to optimize is you have to really spend time being extremely aware of the different services, not just from a pre-built service standpoint, but the different options that you have. When you think about what are your cloud computing options between Azure, AWS, GCP, being aware of where the differentiators are for each of those services, and using the right technology, the right platform to build specific things is also goes into awareness and being able to be a good analyst. It's a difficult question to answer because I think in general, cloud is just a computing framework for analysts to perform. What the nuances of certain clouds is where you'll and the cloud services is where you'll find the value if you dig deeper, which is one of the key takeaways from this section, which I'll get to in a bit. But that's something that you need to think about. That was a very long-winded answer, but I hope that explains it.
Thank you, Harsha. The next question is, does the analytics approach differ as per sector, like for tech sectors or the financial sector?
That's a great question. The approach doesn't change. What really changes is the regulation that each of these industries have put restrictions on what you could do with individualized data. As an example, and I'm sorry, I'm not able to translate this back to India. I should be, but I'm not able to. But in the US, what happens is a credit card marketing company, because of regulations around fair lending policies, et cetera, can't really use customer ID when they're doing like targeting, or they cannot use a customer profile when they're targeting because of the fair lending policies. That could be a limiting factor in terms of what data that you can get. Same with in healthcare with regulations in healthcare, you will have a lot of restrictions on what you could do and what you can't do. Tech in general is not that regulated. Obviously, the scenario is going to change as Google, Facebook, and some of the more consumer-oriented companies like Amazon, Google, and Facebook come under. This is a huge topic in the industry in general. Privacy laws are becoming stricter. There's a lot that goes into regular industries that tech is not impacted by. So the analytical approach is not very different. The problems that you're dealing with are industry specific. The technologies are pretty much industry agnostic. However, the regulations and compliance sort of make it extremely interesting in terms of things like data, what data you have access to, where you can persist that data, et cetera, store that data, et cetera, are things that you have to really think through before approaching a problem.
One more question. Please name resources from where an undergrad can learn cloud computing basics.
Yeah, this is where I really struggled when I coming up with the topic itself. Is some of this might seem extremely daunting, but some of these are extremely easy to get familiarize yourself with. The first area that I would say is go to Azure. If you search for Azure Learn, which is Microsoft's cloud, you will find resources that there's a lot of free resources, especially for students. And one of the things that I can potentially follow up with Microsoft in India is if there's something that we could do BITS Pilani specific in terms of delivering cloud training for people on the Pilani and the Goa campus and the Hyderabad campus. Something that I can take back with. But a lot of knowledge already exists, or resources already exist in the free educational sort of material that exists from all the public cloud providers. The same is true with Azure and AWS. The one thing that I will say is you think about how do you familiarize yourself with the cloud. Stick to one cloud, right? If you have good understanding of, I will obviously speak for Microsoft because I'm a Microsoft employee. If you learn Azure, it gives you enough of a foundation that you can then, if an organization that you get hired into uses AWS and Google Cloud, some of those skills are very transferable. So pick a cloud, stick to it.
Harsha, thank you for that. Maybe please continue with your rest of your session, and we can wrap up with the last set of questions. Thank you.
Yeah, so this probably is not extremely legible. If you see, this is where I come back to the original question that was asked. What does a business analyst do? What does a data analyst do, or data scientist do, or a data engineer do? So if you think about organizations in general, like there's several ways in which you can draw this architecture, but at a very fundamental level, you have where data gets.
Thanks.
कौन है यहाँ पे?
Can everyone mute your?
Yeah, that's fine. Somebody's probably already in the mess. So I'll try and pick up pace here. So you have all of this like data that's being originated here. All of that data gets persisted in some form of, or stored, persisted meaning stored in some form. a data engineer really deals with figuring out how to bring the data into the organization. That's as simple as it can, as I can state it. A data scientist, basically what they do is they take this data and then figure out how do you really build models to predictive models, etc., that can then be delivered to a business analyst that looks at a dashboard or a reporting tool or an application and basically interpret those results back to a business user. So as an example, a business analyst would be someone who would, let's say you are Flipkart, and Flipkart said, hey, I need to figure out how many orders are going to originate from Hyderabad or Mumbai over the next 2 days. And and to answer that question, you have to basically be able to build a forecasting model that says what is demand going to look like for a particular product over the next 2 days. A business analyst would basically define how can we potentially forecast, or what data can we use. And so he may define it as, let's look at all the orders from the last 3 years and look at how the orders have been growing year on year because e-commerce is growing. And let's look at seasonality associated with which due days. Is it Thursday, Friday, or Friday, Saturday? Sometimes Friday, Saturday might have different levels of orders. And then figure out what else data that exists within the company that can help, right? During the pandemic, you may have a lot more of certain kinds of products that are being ordered. So business analyst really gives guidance to a data engineer on, like, here's probably some of these elements that we can probably look into to be able to bring. And then the data scientist and business analyst typically collaborate in solving these problems, where a data scientist would eventually take these inputs and build a model that the business analyst would then consume and then deliver to the head of supply chain or head of marketing that's making a decision on whether they need to do a promotion to increase more number of orders, etc. So those are like things that business analysts and data scientists do. Now, I say all of this. If you think about how I would think as an MBA student, I would try to get some amount of technical skills in being able to understand things like forecasting, etc. Because every company that I know of, data science, machine learning, and AI is almost pervasive in every conversation. I don't care if you're someone within the finance organization that is counting beans, or somebody who is in supply chain who is trying to optimize delivery routes or things like that. All of these processes are being transformed. And if I was back in and I was telling my friend the other day, the biggest regret that I have from my BITSian journey is I've not spent enough time. Even back then, there were courses like machine learning and AI. There was actually a course at I'm sure it was available in the Pilani campus as well, or around computer vision and using sort of computer vision as sort of, and that could have given me a lot of foundations that would have helped my career even more. What I'm trying to say is, as you're going through an MBA course, don't stick to just trying to do marketing or specific, and business-centered courses. Also focus on your technical skills, although you may not be excel at it, because at the end of the day, what you're trying to build during the MBA process is some foundational skills and understanding. So when you go into the industry, you're able to understand what people are talking about and have come to your own judgment. I'll also, is one of the biggest takeaways that I have from today's presentation is read a lot of, so all the public cloud providers like Azure, Amazon Web Services, and Google Cloud publish case studies on how they're doing analytics. And the same thing with Boston Consulting Group, Bain or McKinsey or Deloitte. They also publish case studies on how they're dealing with these problems. If you're working in an industry, make it a point to review what is going on in the industry every week, because that is how you will sort of understand what is really happening and how are people using technology and data to really transform organizations. That becomes your feeding function to help you really grow. Because you cannot be so hyper focused on what's just happening within your company. You need to really think about across industries what's happening, so you can then translate solve for some of the unarticulated needs of your customers using data and AI. Because I promised I would wrap this up by at 5 after the hour, so I'll sort of pause here and see if there are any final questions before I wrap up.
Great. There are a few more.
Yeah.
So which should a company hire, an ML and AI engineer with some business knowledge or a business analyst, and why? That's a very difficult question to answer. It really depends. I'm not giving you a straight answer, but what I would hire if I was running a company, I would hire someone with basic knowledge of data science. So I'm talking about an MBA profile, right? It really depends on what job I'm hiring for, right? If you have to be my chief of staff as a CEO, if I was a CEO, if I have to hire for a chief of staff, I would hire someone who has good business knowledge, but understands technology and analytics enough to be able to knowledgeably challenge people within. You don't necessarily, as you think about leadership positions or how do you grow your career, you don't really need to know the answers. What you really need to know is the right questions to ask. And the ability to ask the right questions comes from familiarity. It doesn't come from having a PhD in a certain topic, right? So I look for people who are generalists so they can be broad and then figure out where they want to go deep. So I'll always choose a generalist over a specialist in a specific function. Having said that, the way you become a generalist is you start with what you know and then like start expanding your peripheral knowledge and then expand into other areas. Hopefully that answers the question. Thank you. So the next one is, what kind of challenges do companies face while trying to adopt cloud transformation, and how do you overcome them?
I mean, these are extremely good questions, and I'm not surprised, but I'm definitely impressed. I think you guys are asking some very good questions. So there is three things that really depending on the kind of organization that you're dealing with. If you're a startup, you're born in the cloud, there's no challenge in adopting the cloud. But if you think about, if you're a ceramic manufacturer like Rack Ceramics in a Pondicherry, you don't have the right talent within the organization to be able to leverage the cloud. If you have to build a model using data science and AI, you don't have the skill set within Pondicherry to be able to hire. You don't have enough margin within the industry to be able to compete with the Amazons, the Microsofts, the Facebooks of the world to hire the right talent. The biggest challenge these industries have is, or some of these organizations have, is one, a lack of right talent within the organization. The second thing is, again, comes back to awareness of what is possible. Sometimes some of these companies, as an example, I use Rack Ceramics. So one of the things that they could be doing is use AI technology to figure out whether a tile is built the right way, is the texture coming out right, etc. Instead of having a human being. I actually did my PS1 at a ceramic plant floor, which is why I'm giving you that example. I don't know if they call it PS still, but the practice school one. So they could be doing that. and if I go back to that PS1 organization, they probably don't know where to start even to solve for that particular problem. So there's a lack of skills from a personnel standpoint. There's lack of unawareness are two of the biggest challenges. The way we are really, I can speak for cloud fraternity in general, not just for Microsoft, is they're making it extremely easy by offering finished services to customers, right? That makes it extremely easy. So you don't have to have a data scientist to be able to build a model. You can have a business analyst that has some basic understanding of how things work and integrate your data to the kind of problem that they're trying to solve and eventually produce a result. So that's one of the things. The second area that they're investing in is training, right? If you find a lot of resources like Microsoft as a skilling program, Microsoft themselves said they're going to invest up to 300 crores in skilling across the world and paying for people's certification, etc. So they're able to bring the average human being to a level where they're able to understand what the cloud could do for them. So the skilling and sort of making the cloud services easy to use are two things that they're working on.
All right. If you could explain the scope of business analytics in real estate infrastructure companies, that would be great.
Yeah. Again, a great question. My father is a commercial real estate developer, so I have a certain amount of passion about this. I think there's several ways in which you can use data in the commercial real estate industry, right? One is to figure out what price you need to acquire the property at, because you have now, if you digitize all the transactions, it's not extremely prevalent in India because there's a lot of under the table transactions that happen. So you really don't have the vast amount of knowledge. But if you look at what's happening with Embassy Real Estate Investment Trust in Bangalore, where they have a lot of properties, all of their rents are publicly published, etc. You can do a lot of analytics around the right price point you can pay for a building, right? That's acquisition is an area where you can use analytics. Operationally, you can use analytics to understand things like the maintenance, right? Things that are extremely used, like an elevator or an escalator. How do you use data to predict when certain elements would fail within the commercial real estate space is an element that you could do. Third thing you could use data analytics around is how are rents growing over a period in time? Like what is a good rent to get for a particular property? And then even disposition, you can figure out what the price point is, etc. So operationally, there are lots of areas where you can use commercial real estate data and